Jai Jindra, Namaste and welcome to my channel. Today we are going to solve the 68th question of the problem solving series and the fourth and the last question of recursion in this playlist. The difficulty level for this question is medium and this question has been asked in many companies like Google, Amazon, Uber, Microsoft, LinkedIn, PayPal, etc. So let's look at the example. So we are given an array like here 2, 3, 5 and we are given a target number that is 8 here. So we need to find all the combinations of this array, like the subsets, whose sum is equal to 8. But the thing is, here a number can be repeated. The subsequence should be unique, but the number can be repeated. For example, one sum is 2, 2, 2, 2. This 2 has been taken 4 times. So this is one sum, but like 3, 3 is 9, so it could not be, this won't be the other sum. The other sum here, it would be 3, 5 will be 8. And do we have any other option of having the target 8? 2, 2, 2, 2, 2, 3, 5, so we can't take 5, 2, 3, 3, 3, 3, 9. So these are the only two options, I think. No, 2, 3, 3, right? This can be other option. So this will be our answer, right? So how do we do this? So we have already solved 3 problems and we know how do we use recursion. We need to find the base case. We need to build the recursive stack, and till now we have used that same pattern, pick and non-pick. And since this is also a subsequence kind of thing, so either you are picking the element or you are not picking it. So we'll be using the same logic in this problem as well. So how do you think of the solution now? So you know, I have solved already this kind of questions. So we have this array like 2, 3, 5 here. We are discussing the same example, and now we have got 2. We have the option of choose 2 and not choose 2. Okay, so if we choose 2, then every time we were moving to the next index. But here, if we have chosen 2, we have the option of choosing 2 again till the time we don't get the target. So when we choose 2 for the 4 times, the sum becomes 8. So we get the target sum, and that becomes our one of the sum. Then we can actually not choose 2 and go with the other path. Okay. So this is one change that is there in this problem. Otherwise, whenever we get the sum as target sum, we have that all the elements in our vector, and we push array and we push that subset to the larger subset. Okay, so this is kind of similarly, only this change is there. Okay, so let's code it. So what do? We declare a 2D array, 2D vector, say answer. Okay, and we have a 1D vector, say ds. Okay, and we find we call a int count equal to count subsets. We'll use camel case, count subsets. And what do we pass? We pass array. Okay, we pass the index. We pass, we have set int n is equal to array dot size. Okay, we pass n, and then we pass n, we pass answer, we pass the vector, ds vector, and we pass the target sum. Okay, and then we define this recursive sum function, and we return count. Okay, and here int count subsets. Let's define it in the right order. We have array, given array, vector int array. We have int index. Okay, so this index is we start with 0, so we pass 0, which is int index. We have n as the size, we have answer, okay. So answer is vector of vector int answer. We have vector of vector int ds, the subset, and we have target. Okay, we have defined all of this here. And now what would be our base case when the index reaches the last element, right? When it crosses the last element, then we check whether we have reached the target sum or not, or the target sum, since we are not passing any other sum to compare with the target, we will see if the target becomes 0 or not. We will subtract the values whenever we pick the element. Okay, you'll understand. So if index is equal to n is our base case. So what do? We see if target becomes 0, then we push the subset that we got into the answer vector. Okay, we do this, and then what do? If index is equal to 1, we do this and we return. Okay, our work is done for this one. Now if we when we form this thing, right? So what do? We select the element, right? So first we can select one element multiple times, right? So we will have a loop here for int I equal to index I less than n and I plus plus. Okay, so here we select this ds dot pushback, this array element. Okay, this 2 we have selected into the vector. Okay, this vector, and then we call and we see. Okay, first we see, before choosing, we see that okay, since we are going to have return unique subsets only. Okay, we won't repeat it. Like 2 3 3 is there, so 3 3 2 won't come, right? So the subset should be unique. So we'll see, and if suppose there are repetitive elements 2 2 3 5, then 2 is same. Okay, it won't be repeated again. So we will see. Okay, if index is greater than 0 and array of index is equal to array of index minus 1, then we will continue. That means we will not check for this. We will again try with a new element that is not redundant. Okay, and if array of index, if array of I, okay, this should be I actually, not index. Okay, we are using I minus 1. Okay, if array of index, if it is greater than target, that means we need to break, right? Because no point, we are not going to take this element, so we will break. Now the change is we will push ds dot push back to array of I. We have pushed this element to the ds vector, and now we will call count subsets, and we will pass this element array index. The index won't increase because we will repeat this, right? So we are picking this, and we are passing answer, we are passing ds, we are passing, and target will be target minus array of I. Okay, so target will decrease. Okay, so we are calling this, and actually we are not returning count, so we are need to pass this we are just calling this would be a void call. This will be a void data type call, and we will call this and then we will return answer, because we will get our answer as the 2D vector which contains all the subsequence whose target is 8, or whose target is the defined target. And once we have done this, then we will pop this out. ds dot pop back the element which we have passed. Okay. So once this loop is done, so we have picked this element. This is picking. And then we will not pick. So when we not pick, then we count subsets, we pass array, we pass the index, we pass the n. The index will increase now. Index plus 1 would be passed, n would be passed, answer would be passed, ds would be passed, and target will not decrease now. Okay. So since we will not select the element, and then both these functions will be called, and we will have our answer as this answer vector. Every time we will have, whenever the target becomes 0, we will get all the subsets whose sums is equal to the target. Okay. So I'll not draw the recursive function here, recursive tree here, because this is simple. We have already discussed the previous question. The previous question was very similar to this, where we had to count all the number of subsequences whose sum is k. Here we need to find the subsequences whose sum is k, and element can be repeated as well. Okay. So the link to the question is given in the description. Please try it yourself and then come to my code walkthrough session. The time complexity would be exponential since it's a recursive solution. Here's the code walkthrough of the 68th question of the problem solving series. You can see this has come in a lot of companies, and here is the example that we have discussed, and here we'll see the other example. 2 3 6 7 is the candidate array, and the target is 7. So the outputs are 2 2 3, which sums up to 7, and the 7. So this would be our output. So we can look at the solution. It is same as discussed. Only the thing is, we have here, instead of running it in the loop, we don't need to run it in the loop. We can just have a check whether array of index is less than target or not, because if array of index is greater than target, then we need to this condition will not be there. So we push the element array of index, and we don't increase the index. We just reduce the target value by array of index, and then we pop this value again. Okay. So here we are picking the element, and here we are not picking the element by not subtracting from the target and increasing the index, and the base condition remains the same, that if index reaches the array equal to size, and if the target is 0, we are pushing the ds vector to the answer 2D vector, and we are returning. Okay. So the only thing is this one, array index is less than equal to target, then we keep on taking the same index and subtracting the value from the target. Okay. So that is the thing. So we'll directly submit this. So it has been accepted. Okay. So see you also in the next video, where I'll start a new topic, and that is backtracking. Okay. Jai Jirendra.